Hello and welcome everybody to our presentation on FME and data validation. This is Mark Stokes here. I'm the Manager of Support here at Safe Software. And with us today we've got George Crow and Dave Ellerbeck. George is with Colonial Pipeline and has done a lot of work with their CAD systems at Colonial Pipeline. Dave is with Global Information Systems, and he's a consultant to Colonial Pipeline and has been working on some of the data validation problems that they've got. So today's webinar, we've got a presentation from George and Dave on their experiences with using FME in the context of data validation at Colonial Pipeline. I believe also with them is Eric Klein, who's there for moral support for them. Also with us today, we've got Robin Rennie and Dave Campanis from Safe Software, and they're sitting here ready to answer any questions that you might have. So in your GoToWebinar panel there, you can chat us any questions on the presentation material or about FME. Maybe just go to the next slide there, Dave. So for those of you that don't know who we are here, we're Safe Software. We're in a suburb of Metro Vancouver. Here's our offices built up in Minecraft, which is a new writer in our tool set. If you don't know very much about us, just go to safe.com and you'll learn a bit more about us there. So that's enough of an introduction. We've got a lot of material to cover today, so we can go on to the next slide, and I'm going to hand it over to George and Dave, and they're going to discuss their experiences with data validation at Colonial Pipeline.
Okay. Thank you, Mark. I am with Colonial Pipeline Company. Colonial is a midstream company in the east coast of the U.S., primarily transporting refined petroleum products along the east seaboard. I'm not going to go through all of the slides here, but we are a fairly large operation with over 50,000 linear miles of pipeline stretching the entire eastern seaboard of the United States for the most part. Again, dealing strictly with liquids, refined petroleum from gasoline to and all the grades you see there. I won't spend a lot of time on this. I just want to make you aware of kind of the data set that we are working with. We are somewhat unique in that I don't have a CAD department per se. Much of the project management, engineering, drafting is handled by external contractors, one of which happens to be sitting here with me. And just to give you an idea, regarding the infrastructure within Colonial in regards to engineering, we have somewhat of approximately 75 engineers and project managers stationed throughout our system. They're supported by over 20 engineering and design contracting firms. Within the corporate structure in the suburbs of Atlanta, Georgia, where we are, we have roughly 6 personnel that manages all the data for those 20 engineering firms and 75 plus contractors. Of those, 2 are primarily CAD operators or CAD personnel, 3 GIS personnel, 1 manager, which is me, which means there's really 5 people that actually does something. So needless to say, we have to rely heavily on our consultants and contractors to keep us in line with the drawing set and the like. Basically, again, working in the AutoCAD environment, one of the things that we are constantly working with is trying to validate the data that is coming back in to us from those various field locations and consultants. Obviously, when you're dealing with multiple organizations throughout the continental U.S., keeping your CAD data in some type of standardized format is paramount for us. And so we are constantly looking at ways of auditing this. We have a very comprehensive drafting standard, but then how do we keep that standard intact in regards to the drawing data that we are provided back at the end of a project? So basic workflow, again, this is very basic. Project management personnel will work with contracting personnel, and then at the end of a project, send that as-built data back into our CAD GIS team. Well, we have to look at that pretty much on a per drawing basis and validate that against our drafting standards, and then try to generate some type of report and understand where we go from there. This is a very arduous process within the Autodesk environment, although it does have some good tools. Some of the basic tools that you will use within the AutoCAD environment is the DWS structure. There is a drawing standard format that can be configured within the AutoCAD environment, and that is basically, or is based upon, 4 primary entity groups: dimension styles, layers, line types, and text styles, which are configurable within the drawing standards format, which so each individual drawing can be audited accordingly from the end of report generated on a per drawing basis, or batched, if you will, and then someone has to go in manually and make the necessary changes or do the edits accordingly. Some other tools that you have in the AutoCAD environment is a lay walk command, where you can physically walk through a drawing. Of course, the drawing has to be loaded, working inside the AutoCAD environment, to look at various layers and ensure the entities are on the correct layer. Some other tools are layer translator. Once you determine errors or things that must be changed, there's layer translator mode or command that allow you to, somewhat in an automated process, transfer entities from one layer to the next. But needless to say, what I'm trying to get to is this is a very labor-intensive process. Good tools, but still very labor-intensive. So we always ask the question, how can we improve our process? How can we get this beyond the human element and automate this as much as possible? 2 ways that we want to look at this. One is in place today. Another one we are actively working towards. So the first top row here, and again, a very basic workflow, when files come in from our project management personnel and contractor, we run FME scripts, which we'll get to in just a moment. And then that process automates an audit report, which we look at. Basically, what we're going to show you today is a way of taking a very arduous, very manual task that could take hours and transform that into a process where those hours are reduced to minutes or even seconds in some regards. And being able to look at all aspects of a drawing standard that really goes beyond the basic concepts of what Autodesk has built into their products. For future deployment, one of the things we're looking at doing is even automating it further so that contractors load specific drawings to a server and then using the FME server capabilities to run the reports, generate reports back to both Colonial and the contractor, and even in the future make certain edits within the FME application itself, so that some errors are corrected if at all possible. So one of the things we're really looking at here, we want to go over, first and foremost, we want to automate this as much as possible. If you can reduce the mundane tasks, then you reduce errors. It must be scalable. What we want is tools that can be run on an individual basis, on the individual PC, or that can be run in a server-based environment across multiple drawings, multiple platforms. Of course, cost is always a big factor. If you can reduce time, you're going to save cost. And again, one of the things we found very early on is we're reducing the time with validating and editing and correcting all these drawings from multiple hours to just a few minutes, or like I said, in some cases even a few seconds, which is a great cost savings, both from a project perspective and personnel perspective within an organization. Fully customization, within the AutoCAD environment is ever changing. I think we're always dealing with new versions at least once a year. There are changes within the AutoCAD infrastructure. Every 3 years, there's massive changes within the AutoCAD DWG format. Drawing standards change, company, corporate needs change, so the customization features of this has to be there. So we'll discuss ways that we have automated and customized this approach so that it's fully sustainable. And that's the key word I think that I wanted to click on here and really emphasize is sustainability throughout this entire process. So our solution in all of this is FME. So I think at this point, I am going to turn it over to Dave Ellerbeck, who is our FME guru and all-around nice guy, and he is going to take us through some of the processes that we do have implemented.
Okay, so what really happened here is Colonial approached me and asked me if there was a way to pretty much expand on what Lamar was talking about with the Autodesk functionality. So, the obvious things were is that FME was really good at reading, the obvious parts, 2D and 3D lines or graphics or layers and line types and, et cetera, the basic Autodesk infrastructure. Some of the additional things we had to do were things like blocks and block attributes. As you have to notice in the QC slides before, there was nothing in there about attribute values. Well, in this case, there was need for checking if one attribute was filled out and another one filled out, or if that one's filled out, then another one has to be filled out. With FME, we can read the text and we can also read the text value, which means we can test against that. Extended entity data, paper space, model spaces, and block inserts, so things like XREF. And these are all functions that were needed for Colonial. So what we did was, we used this standard FME workbench in here. And we started out with, and this is kind of a little misleading slide, is that we started with just manipulation, comparison, replacement, and then also with logical tests, data integration, queries, aggregation, all the normal functionality. And kind of on the right side, this is how the whole thing started. And this has gone through about 3 iterations now. And starting from the very basic proof of concept, saying that yes, I can read a line on a layer and make sure it's on the right thing, to some of you might have seen other presentations we've done where we had everything hard-coded directly inside the workbench, to the point where we're setting at now where we actually have created a dynamic workbench that can read sets of rules and follow all these objects and manipulation that we were wanting to achieve. So the other reason for FME was to, we can write to almost any supported format. So, we can write it back to CAD. We can write it to a database. In case Colonial, they have an FD database along with, their AutoCAD files. And so they might want to share some of the data between them, but only if the data is clean. To other GIS formats and to just about anything that they have internally inside of the company. So what our approaches were is making it standards-based, so kind of like what the Autodesk users are used to now, but we wanted something that would be standards-based, well-documented file, something that was easier to read for Autodesk users that might not be familiar with FME, and that you could use as almost a production document and also as your sets of rules. Repeatability, kind of like you mentioned earlier, is repeatability sounds normal through a set of tools, except that users tend to skip a file on a Friday because they want to go home, or accidentally miss something, or just overall might be lazy, or easily just skip something. Emphasis on automation was a huge one, so we didn't want to use the current process where you open an AutoCAD file up, you step through a set of tasks, you go through all these rules, hopefully the user gets them all, and then you're done with it. We wanted to make a one-stop shop for everything that Colonial has. And then ultimately, the report orientation for this. What we want to do is identify and report all errors, and we'll touch base on this a little more, but we need something friendly for the users to, so they can read it and understand if they're going to accept the file or reject it, or even give them a way to find the problems inside the files. So what did we do inside FME? We used as many out-of-the-box transformers as we could, so we built logic into an FME workbench that simply used out-of-the-box transformers as simply as we could, so that way the script didn't get too confusing. We replicated logical tests, so in the case what we're doing is we check all the layers in one place, we check all the blocks in one place, but we use the rules to define what it's going to be checking. We use some custom transformers, and like I said, subroutines, and that's simply for things extended that we knew that Colonial needed. Things that like naming conventions, or checking certain attributes, something that wasn't just an out-of-the-box option. And then a standardized reporting approach. So we wanted a standard document to come out, and everybody could look at it and understand exactly what's going to happen. So kind of now is the let's take a look at it. What we have here is we'll start with the Excel file that we're actually using right now to generate the rules. And this is simply a way to input rules, and this is going to go through iterations as well, but eventually it'll probably turn into something more of an interface on a website or something like that to write into a table. But kind of what we wanted to show you in here is this is customizable with FME, and there's this huge long list of what these are, the FME's AutoCAD format attributes. And we expose all those to the end user, but for most people, they're going to look at AutoCAD colors and maybe the layer and the layer color. So you can compare if somebody changed a line to red versus it's supposed to be red because of the layer. Block names, all the information that FME has inside of it, we expose that to the user right there. And then they go through and they can set up custom parameters, equals, ends, uppercases, things like that that most people will be able to use. Plus being able to put in a customized message and also a level of severity. So if they want to reject it because they have the wrong name file, they can. It goes through other things, such as block attributes, so we can check out the date format. So in this case, Colonial always uses, the 2 number, and 4 numbers for their dates, and you can customize that as much as you want. Other things, these are one of our favorite ones, is they have a naming convention for the file. So inside of here, using these, we can check the actual AutoCAD file name and compare that to what the users called it. So if they missed a 0 at the beginning of the number and there's supposed to be 2 numbers there, it's going to flag that for them. It also goes into georeferencing, which that one gets a little more complicated, but we can make sure that the files that need to be georeferenced are georeferenced. So inside the FME Workbench, this is much simpler than it sounds. So these read the Excel file, and it's simply using a test filter to look in what kind of rule types it has. And based on the rule types, it adds an attribute inside of here to write up the query that's needed for those rule types. So we can kind of go in and look at it. So here's a set of information. So it returns the rule name, the error message, the severity, and the actual filters that are going to be used for returning the information. Now, Lamar and I kind of talked about this earlier. I understand Autodesk, and that's one of the caveats of doing this, is that you have to understand what format you're coming from. So if you're a MicroStation or an ESRI shop, you have to know your underlying data for it. In this case, we are converting the AutoCAD files to a SQL format. And when I say SQL, it's a SQLite database that the FME script generates. And this is where all the reports are running at. And so it goes through and it generates a SQL executor and it returns information. So we can go through and take a look at this, and we can use the normal Open Advanced Browser. I have 3 files we're using right now. And you can add whole directories. I've added up to 200 files on this to check at the same time. But in this case, we're just going to use the 3 of them. And I can go on here, and I'm just going to tell it to write out my HTML document in this case. That's the platform we chose. So I hit OK to this, and this is going to run out, and it's going to grab the 3 AutoCAD files. It runs through the process, or runs through the Excel file every single time to get the new sets of rules. And once it's done, of course, it's going to make me look slow today.
Well, the gist of it is, for these 3 files, if we were doing this through the AutoCAD environment, we would have to open these 3 files, or we could to some degree batch it. But for the most part, you open each of these files within the AutoCAD environment. You run the check standards function. You've done your layer walks. You've done the layer transformations and other tools within the AutoCAD environment. So this turns into a very arduous, very time-consuming process. Now step back into this, and we're done, right?
Right, yeah, 12 seconds for 3 files. And for the 200 files I put in there, it was around 15 minutes of time to generate all the errors for those files.
It would take longer to actually launch the AutoCAD application than it would than it took to even run through these 3 files.
Right. And so what this has done, though, is this has given us our FME demo output in an HTML format. And this is kind of the format we've come up with here. And you'll see up here, the first file name. It has 182 elements that were checked inside the AutoCAD file. There's 38 errors, and we can look at the percentage error for it right away. And if Colonial is accepting 95% or above, they can simply look at this and say, well, I've got more than 5% errors. I'm going to reject this. Or they can look at it over at the same time and look at the summary of errors that are setting inside of the file. So on here, he can't have anything on layer 0. Well, there's 9 errors on layer 0. There's 6 missing layers. There's 5 title block errors, and so on down it. And one of these rules automatically send a rejection back to the vendor saying, that they can't accept this file because there is something major on it. Well, what we do with that is this is linked down to it, and we can go as far as into the file itself. And in this case, we can look at the layer 0 errors there at the top, and I can see that I have 2 errors on model space sheet 1 of 2, multi-text, and it's on layer 0 is the actual error. So the AutoCAD user can then go into AutoCAD, they change to their model or to their sheet 1 of 2, and look for any end text on layer 0, and let them select it and move it to, say, the text layer. It goes down to looking for missing layer names inside the AutoCAD file. So there's a basic set of layer names that have to be there for reporting reasons, and they're not located in here. All the way, and then we also have things in there such as the naming conventions. Their facility code does not match what their definitions are. We can see that we have invalids in the S7 BDR block name. And so it's a very, very nice approach of getting back your error messages for it. Plus, Colonial can audit these and hold on to these files as long as they want and see possibly which users are making errors constantly. And if they're, while they're making these errors, we can also take a step back and say, okay, well, does your user need more training, or why are they constantly sending these errors to us? Some of the things we have here are the known limitations for FME in the AutoCAD file. Currently, we really have a desire to take the CAD files, and if it's something simple like a line on a certain layer that has the wrong line type, we'd really like to be able to fix those. And FME can definitely do that right now. The issues that we're having is saying writing multiple layouts. So Colonial will put 5 layouts into an AutoCAD file, and each one of those layouts is a different page for a plot. And right now, FME does not have the ability to write them back out. It can read as many of them as we want, but writing them is a little bit of a difficulty. Along those same lines are the plot parameters, and that's simply because FME is not a plotting engine. It's not made for really plotting out of Autodesk, and it's not going to check the plotting standards for it. But that's a fairly small piece of that.
One caveat to that is you can write out to a PDF. Is that correct?
Yes, absolutely.
Yeah. So if you wanted to write out to any type of electronic format, if that was going to be something you wanted to disseminate to others, or even send to a printer, yeah, you can certainly do so.
Yeah, absolutely. You could tie in there and see if your percentage of errors are down to something, and then write a PDF file that will look exactly like the AutoCAD file, and then you could split it up by model space into pages. So yeah, you can create a plottable file from it, but it's not checking Autodesk's current plotting piece of it. And our last limitation is always your imagination. So you can see there's a lot of options inside FME. So really what you can imagine, you can do it inside of there. And our approach, we're really liking this because now our CAD users can learn one location and use their imagination to tie together all of our tests that we have in order to generate new rules or interactions inside of this file that drives the FME workbench.
So if you have a very robust CAD standard, which some have, and especially if you're working within a government issue or a public company, some CAD standards can be volumes of information, or down to just a basic concept of having a DWS file structure, which really defines basic dimension styles, text styles, and the like. So regardless of the complexity of a standardization process, it could be fully automated to really take you beyond the AutoCAD environment, which for me that was big. Being able to do this outside of the AutoCAD environment just saves so much time, not only in just licensing of software and training of users for the software, but just the time alone is definitely worth the effort to really investigate this further and see what can really be used in this regard. Being fully customizable within that Excel spreadsheet is really great. Again, as standards change, you modify that Excel spreadsheet, which ultimately for us means really taking that to automate this entire thing. What we've shown here is really a process of automating the validation, although the changes currently are more manual due to the limitations of either writing out to multiple layouts within a CAD file. But basically, it's really because we use this as a learning tool for our contractors as well, and others. It's not enough just to say, hey, I found an error, but to really describe that error and use that as a training process for contractors so that we all grow in our processes all along. But eventually get to a point where we automate the fixes. So regardless of, unless it is something really bad with the drawing, we fix what we can, thus reducing the back and forth with the contractors. We still report out on it. We still report the errors, but let FME do what it does best, which is transform that bad data into something very good and publish it back out. So a lot of benefits here. Thanks, Dave, and I really appreciate Dave for his hard work in working through this and helping us get to this product, and we're really looking forward to where FME can go beyond this. So we're constantly working with Mark, so Mark, we'll turn it back over to you guys. Thanks for FME for all you do with us. I really want this to be a good business venture for all of us, and hopefully all those in attendance here will take this at heart and help us put a little pressure on Autodesk and even FME to really enhance this, to give us the tools we need to make our jobs much more efficient. So thanks, Mark.
Thank you. Thank you very much. I just want to point out to everybody that we have forced George and Dave to compress their presentation for the purposes of this webinar, And on this slide here is the link to the full presentation that they gave at our FME user conference last year. So when we distribute the webinar materials at the end of the day, you'll all get an email with the links, and part of that will be this PowerPoint, a link to this PowerPoint, so you'll be able to find their full presentation that they gave, a recording of that, and their slides that they gave at the user conference. So we've had a few moments here for some questions, and so there have been a few rattling in, and a lot of interest in what you've been discussing here. Somebody said they're curious to have a little bit more detail on how you're reading the Excel file and bringing those test rules into the workflow. Dave, do you want to elaborate on that a little bit?
Yeah, sure. Really, inside the Excel file, and again, this is its kind of first iteration. But what you do is you give it a rule name, and then next to it you have your so like a simple input. There's the FME exposed attributes for Autodesk. So I can go through and say AutoCAD layer or color even, and then on the next one you can give it a function. So I can say it has to equal, and then I give it the AutoCAD the color number. And what happens is when FME loads it up, it takes that, it sees that it is a equal, and then it takes the function or the format attribute and the function you want to run against it and writes a SQL statement to it. And that really it runs against a SQLite database that FME writes for me from the Autodesk file. And if something on a layer isn't equal to this color, then throw an error out for it.
Yeah, that's how I saw you doing that. Somebody also asked, as I think you did kind of address this slightly, is whether FME could write out and mark errors in a CAD file as well, so you could sort of redline a CAD file, so visually show where those errors were. I think you could do that if you wanted to. Is that right?
Oh, absolutely. And we'd actually thought of that originally. So the issue we had was only being able to write to one paper space. And so in Colonial's case, they really couldn't follow that, but you could very easily just put a circle out there on layer error and definitely put those error messages out there with a piece of text even. So yeah, rewrite a file out there that you can XREF and go correct them inside of AutoCAD.
Yeah, okay. All right, well, I think we'll carry on. We're going to have another opportunity to address some of the questions at the end of the webinar. So thanks a lot again, George and Dave, for pulling that together and sharing with us your experiences. And I did just want to say that actually I know that Dave had reworked his workflow. So since his initial presentation at our user conference, he actually rejigged the workflow to use that SQLite approach. I think before that you were using the inline querier as the sort of the SQL tool in FME, but now you've moved that out to SQLite. That's correct, isn't it?
Yes, and really you could still use the inline querier for it. We just the issue that I was running into was in the case of getting 200 files at the same time, it was a little easier for me to index that database so that I could get the performance back a little better.
Okay, so when I was doing a bit of research for this webinar, it was interesting to see the variation of what people call this process. So Colonial Pipeline refer it to as validation, but actually compliance comes up a lot in similar kind of approaches. I kind of like the term compliance because it implies that it's up to the data provider to be complying with your standard, whereas validation seems to imply that they're going to give you some stuff and it's up to you to make sure that it's correct. In the end, the process is the same, but compliance seems to lean a little bit towards giving the onus on the data provider to comply with your standard. And of course, other people just call it QA, QC. I just wanted to bring up this trust and verify motto that George had mentioned actually during his user conference presentation. I can't remember which politician George quoted that as being a part of, but he did say in his original presentation that we forced him to compress for today that he trusts all his contractors. He said that they were really good, but he does like to verify their work. So I kind of like that motto for the compliance validation world. We can trust our data suppliers, but we will verify their work. So FME's been used in a wide range of data compliance and validation areas. We've seen from the Colonial pipeline experience that they're kind of validating schema, data models, attributes, and in this case CAD and traditional GIS data. We also have tools in FME for validating 3D geometries as well, and actually we've been doing a lot of work recently on splitting out the error messages so that you get much more granularity on the kind of error message you get from invalid 3D geometry. We're working with some European groups on that. And then also we have the ability to do some validation on topology and network topology as well. So it's quite a spectrum of tools that you can put together in FME for the data validation. And then the other side of validation is kind of individual item validation, and in the geometry context that might be the geometry validator transformer that we have in FME. So that does geometry validation on individual geometries, like does this geometry have a self-intersection or duplicate points or something like that. And then again in the sort of geometry realm you can do comparative validations, like using the Spatial Relator tool, which allows you to compare features based on different rule sets to see how those features interact. Do they overlap? Do they just touch at the edges and so on? And then you can build validation rules around that. And that kind of pattern applies not only to geometry but also to schemas and attributes and so on that you can do. So, and I think one of the tests that they're doing at Colonial Pipeline is just it sounds simple, but you know, in their title block they have different titles, title 1, 2, and 3. So if there's a title 2, they check to see that there is also a title 1 populated, because they don't want the title 1 blank and then some item written into title 2. So that's a comparative test on the kind of attribution that they've got in their tool set. So what you're going to see here in the work that Colonial Pipeline have done, and a couple of the other ideas that I'm going to throw out in the next half of this webinar, is kind of a common pattern where people are trying to put their validation rules into some sort of an external table. It seems to be usually in Excel because people are comfortable working in Excel. Build up their rule set there, and then try and read that rule set back into FME, and then compare those rules, use those rules and compare them against the features that you're reading from the source data set, whether it's a CAD data set or a GIS data set, and then match the data with those rules, and then put out some error messages. And in some cases people also have Excel spreadsheet which have standardized error messages in there, so that again it's easier to maintain. So if these rules and the error messages are maintained in an Excel spreadsheet, it's very easy to update things as you go along. So the next sort of area that I thought I would have a look at today is another presentation that somebody gave for us at one of our World Tour events last year in Toronto. David Reel from the city of Kitchener, which I learned actually recently is used to be called Berlin up to the First World War, but they changed their name, I guess motivated by events in Europe. So that was kind of interesting. And so again, there's a link here to Dave's full presentation. In case I butcher this too much, you can go back and have a look at what he's doing there. And so the motivation, this was interesting. I'm going to quote David here. for their use of validation and moving to validation, one was just really moving from a paper-based system to a digital system. So they really had to validate that incoming data that was being put together through heads-up digitizing. But in the ongoing sense, he says there are many reasons why the GIS data at the City of Kitchener needs to be complete and correct. But the reason in general terms is that there is a continual increase of GIS data being integrated into everyone else's everyday work. And so more than ever, non-GIS data needs to be linked to the GIS features and shown together. Reports are being generated from GIS data and used by others in the organization, and decisions are being made based on these reports and people outside the traditional GIS department. So I think that's probably a very general trend altogether in the world that we work in, is that other people are starting to rely on this data more and more, and so it needs to be cleaner and more up-to-date and more correct. So the kind of work that they're doing at the City of Kitchener is sort of three broad areas of validation. CAD standard checking, so they have a workflow that just does some straightforward checking on the data. Is the data on the right layer, has the right color, and those kind of more cartographic issues. And then they get into kind of more detailed checking. They have three separate workflows actually. So the attribute checker is a fairly sophisticated workflow where they look at each attribute, make sure it's complete, and the data is valid, the value is valid, and that's everything from attributes that might be in a range, attributes that might be in an enumerated list or a domain, mandatory attributes, and so on. So they're using AutoCAD data, AutoCAD object data, so they have their attribution is in the AutoCAD object data tables. And then they also are doing some topology checking there, looking at how different entities join together and so on. And then David also refers to relative checks, and I think this is important. So for the attribute and the topology checking, you can only check so much. So when you're looking at your data, for an example, an extreme case would be, if somebody's digitizing the curb of a road and they put that in on the centerline layer and they color it as a centerline and they put some of the attribution as a centerline, you can do a validation check on that and it'll come up as a centerline feature, but it doesn't mean it's correct. It's still a curb, and there's not much you can do about that kind of level of poor quality. So there are other there is a limitation to what we can validate, I guess. I should just point out that these standard checkers were put together by one of our partners, Consort Tech in Montreal. So they worked with the City of Kitchener on this workflow. And so what they're doing here is they FME reads the submitted 3D AutoCAD 3D map plus the Excel files which contain their rules. And some of the requirements they had at City Kitchener was really to externalize these. The main point really was to externalize these rules so that they're easy to customize and change without having to dig into a complicated workspace and update a simple rule. So just having a quick look at the CAD Standards Checker here. Again, they've got a spreadsheet that's illustrated here. That contains how the standard should look. And what they do is they read this spreadsheet with the Excel reader. They read the AutoCAD data, filter out the layers that they want to actually do the validation against. And then basically just do a big join. And if the join succeeds with all these different values, the AutoCAD layer, the line type, color, then you kind of have an initial test on and check that the data is more or less in the right place. And again, in their case here, same as the Colonial Pipeline folks, they're producing some fairly sophisticated reports, so it's very easy to drill down and find out where the errors occur. They're using the statistics calculator quite extensively to summarize some of the data so that they get the summary reports as well as the detailed reports in their standards checking. So then the second of their kind of tests that they do with their AutoCAD object data is the attribute value checking. So in the AutoCAD object data, they can define these templates that the users have to use. And for example, here we've got the material highlighted and it's an enumerated list or domain. And so hopefully as people add an object onto the layer, then they'll use these values to set the attribution. But that's not always the case, and so people have to do some validation here. And so they put together what looks like on surface, that's when you look at their workflow in FME in the workspace, that's their workflow, but it's a very sophisticated workflow. It reads quite a sophisticated rule set, which we'll have a look at in a second. But the key transformer here is a joiner. So what they do is they join the rule set to the incoming features from the AutoCAD data and then do some comparisons with that rule set. So let's have a quick look at what that looks like. So this is the Excel file that they've put together that's got the rules in here. So we can see the feature type name, which is the layer name, what attribute they want to check, what its length will be, the type of the attribute, whether it's part of a domain list or not restricted to a domain list, if it's a range, whether it's got a minimum, maximum value, and so on. So you can see it's a very extensive set of rules that they've got for each attribute on each entity. So for a gas anode, you can see that there should be 3 attributes on there that they're trying to validate. So what I've done is I've taken their sophisticated workflow and stripped it down a little bit just so it's easier to have a look at. And this is it here. And this is just really the key components of this rule. So of the way this works. So they're using dynamic workflow to read all of the AutoCAD file as one honking great big AutoCAD file, and then they're using the joiner to join in the rule set as a CSV file. They dump out that Excel file as a CSV. They're doing a join based on the layer name, and then what they get out then is a list of rules attached to each record in the workflow. So let's just just run that and have a look at the results in the Trustee Data Inspector. And so if we have a look at one of these, what we can see here in the inspector list of attributes here is what we've done is attached the rule to, let's go and have a look at that material. There it is. So we've attached the rule for the material and its domain codes onto that feature. Down here we've got the actual material attribute that came from the AutoCAD file, and then with some trickery they can now go and compare the value of this material here, which is PVC, with the list that contains the rule up here for the material, and to see whether that's valid or not. So so that's kind of the guts of what they're doing. Now I've oversimplified that quite a bit, and so just in here I've got one of the custom transformers that they built. So for each of the different types of tests they do, they built a custom transformer that pulls together the testing of that rules and figures out from the list how they're going to process that rule. So I've made it look a lot simpler than it really is, but the guts of it is this joiner and then some post-processing on the list that they created to create that rule. So that's pretty cool. Okay, and again, the output is the same, a detailed report that tells them what failed, and a summary report. And I think in this case also they do dump their data out to shapefiles so that people can get a quick visual of where that bad piece of data sat. And then the third of the checks that they've been doing is around topology, and so how the network of data that their gas pipes and so on link together. And you can see here quite a list of sophisticated tests that they're doing to try and pull this data together. 12 topology rules altogether. I think what's interesting here, you can see in this column B here, we've got a minimum tolerance. So FME is not really a tolerance-based system. If you want to know whether two lines join end to end in FME, basically the coordinates of those two endpoints have to match exactly. And in some situations, that's kind of hard to do. So what they've done in this set of tests is to use a transformer called the neighbor finder. You can see in the little image down there that instead of actually doing a test to see whether the coordinates are exactly the same end to end, they're using the neighbor find to see whether the endpoints are close to each other or not. And so the pattern is fairly similar to the one we saw before. They use the joiner transformer on the left-hand side of that bottom image to read in the rule set, and then they use the neighbor finder to see how that's going to look. So let's have a look at that workflow. And again, I've stripped down their full workspace to a much more simplified version. I've only included one of the rule sets here out of the 12, so you can imagine that I've just got this small part of the workflow, but the full workspace is far more complex than this because it's got a pattern for each rule that they're working with. So again, in here, what we've got is a dynamic reader just reading all of the AutoCAD file. He's doing a very interesting and neat trick here. Instead of just having a test filter that says these are the only layers I want to do the topology checking on, what they're doing is using a joiner tool to look at a table that has the list of layers that has all the layers that are involved in the topology rule checking. And so if we get a join, we let those features through, and if we don't, then we drop them off. And so that's how they're kind of got a table of what layers do I want to use for my topology checking. And what's great about that is that is not embedded in your workflow. So if you want to add another layer to the topology checking, you just add it to that little spreadsheet that they've got with the rules in. And then over here you can see that they're using the neighbor finder as the tool for matching, in this case, whether the lines match end to end within that tolerance value. Now the way they're doing that is again very clever. Is what they do is they use the topology builder for each line that they get in from the AutoCAD file, and then they only return the nodes. That's the endpoint of those lines. And then what they do is they take each of those nodes and they compare it with grab the rule set, and then that's what they're comparing in the neighbor finder. So they're only comparing the endpoint. So this is really a point-to-point neighbor finding. It ends up just being point-to-point. It's not a line-to-line, which makes the whole neighbor finding much simpler and actually quite a bit faster. And then they write out the output to the shapefile if it doesn't pass the rule, and off to the error report stuff at the tail end there. So again, a simplified view of a more complicated workflow, but the pattern is fairly similar that we've seen before. Join to the rule and then do some testing on that based on what that rule looks like. And I think we've got, that's the wrong one, I think we've got that spreadsheet to here that we can have a look at. There we go. So you can see that for each of their rules here, we've been looking at Rule 5. These are the different rules they've got for gas main and sanitary main and storm main and so on that they check against. And they've got one of these tables for each of the kind of topology that they want to validate against. Okay, and then on the output side, they've got the reports going out, Shapefile going out, and there you can see they're redlining that. So in the Shapefile, they put a couple of circles there that you can quickly pull up a quick view of that and see where the data has gone bad. So once the data's all been validated, everything's then loaded into the GIS database. They're using an ESRI tool, so it's a ESRI geodatabase, and everybody's happy. Okay, so just to wrap up the webinar, what I wanted to again is sort of butcher somebody else's presentation, again from our user conference. And this is from a presentation by National Research Canada, the Canadian Centre for Mapping and Earth Observation, that they presented on their overall use of FME at their organization, but I'm just going to focus on the part of that presentation that talked about the validation. So the full presentation, which again I've got a link in this PowerPoint, will take you there if you want to see how they're using FME in their organization. I think they've got about 700 formalized workflows they're using FME for different tasks across the board. Ranges from feature translation and feature creation through to validation. And so this here gives us an idea of in their kind of overall workflow where they're using FME at different places, and we're going to be talking about the QA/QC kind of end of it, which is on the data acquisition side of things. And so they have based their validation on what they call a catalog-based validation, and actually that catalog is interesting. It's based on an ISO standard, ISO 9110 compliant, and so that's an XML file that defines the kind of set of rules that you want to validate against in a catalog, and then they can read that data. They're doing a whole bunch of similar validations based that we've been seeing earlier, but also some very clever spatial relations as well. You can see there in the middle some minimal dimension validation that they do on their large-scale maps. The ones that I really like are the spatial relation validations using largely the transformer called the spatial relator. And so within their rule sets, they can build these Eigenhofer matrices, which are really just spatial interaction rules. And if we want to use standard tools, those are the ones that you would have that are called intersect or inside or within touches and so on. But you can really fine-tune those rules with these 3x3 matrices that tell you how different features should interact. And so the way that's done is within this catalog. This is an HTML redention of that catalog. And the catalog defines how a couple of features should interact. So here we're looking at an island entity on the top image there. So this is the spatial constraint. And so an island entity has to be in a water body of the type ocean. And that is a one-to-one relationship. So not only do they have the spatial constraint on each of these rules, but they also have the cardinality, and you can see this is a one-to-one relationship. So we can, if we have one island, it can only be inside one ocean. But in other contexts like rivers and water flows, you could have a river that touches a lake at either end, so that would be possibly a one-to-two relationship or a one-to-many kind of relationship. And in addition, they have within that catalog, which is XML-based this time, not Excel-based, they have the attribute validations as well. So the pattern is the same, similar to what we've been seeing before. Somewhere they read in the rule set. They actually do pre-process this XML file from the ISO standard into a more list-friendly format, they call it. That's where they're using the joiner transformer to join the rule to the data that they're reading coming in from the left-hand side here. And then in a similar pattern that we've seen before in the other two presentations, they've built custom transformers for each of the validation rules that they want to work on, or I should say validation types, so whether it's a spatial validation, attribute validation, and so on. So they have a custom transformer for doing that spatial validation in this case maybe, and then they have another custom transformer that they've built that pulls together the error formatting and allows them to spit out that error message and so on. So one custom transformer built for each sort of validation rule concept. And that's just an example of one of their workflows that they've put together. So that's a quick run through of what NRCan have been using FME for on their validation side. We haven't really talked too much about automation, but that's where FME server would kick in. So all of these rules are repeatable, all these validation tools are repeatable, and so we could automate those. We've got an example up on our website if you want to have a look at that. So you can go and look at that data validation example where you upload a CAD file and it'll give you back a report through FME server. So you know, that would be the next step for some of these organizations, is to automate these rules or make them available to the consultants in an external web form so that you don't even have to see their CAD file. They can just validate it themselves. If it doesn't pass, they just take it back. So that's one approach as well. Okay, so just within this work, within this PowerPoint set, I've included some links to some other resources if you want to explore data validation with FME. So Tiana, one of our colleagues here, has written a great blog on geospatial data validation with FME, and she's got a checklist there on what you can validate against. And there are more super customer stories from various presentations that people have done either at our user conference or world tours. And as I said, I've given you links to the full presentations for both Colonial Pipeline and City of Kitchener and NRCan here. So we can have a look to see if there's any questions there. Robin, Dave Campanis, we've got a lot of Daves today. Do we have any other questions that have been sneaking in that...
Oh, I was just going to say there was a number of people wanted to know if we understood that we couldn't give out the customer workspaces, but this second set of workspaces that you went through, are they going to be available on the website?
I'll ask David Reel at City of Kitchener. They're from him, derived from ones that Consort Tech put together for them, so we will ask them, and if we can, we will post them up.
Yeah. That's what I thought. Good, thank you.
I was going to say the same thing, Robin. It looks like the most common question is, can people get their hands on the workspaces? So they're very highly sought after today.
Well, they were very interesting concepts, and I think it's a little much to take in just a demo. You really want to analyze those workspaces and see what's being done in there.
Well, it's very clever to see the various ways that the intelligence can be moved out of the workspace and into external tables or spreadsheets, and then you use FME in a clever way to apply those without a lot of logic in the workspace, but the real business rules being held externally.
Yeah, and then that makes it so much easier to maintain the whole package. So
yeah, it's great, and you can see a very common pattern there. Put the rules in a spreadsheet or a database, and then read them back, and maybe that's in our development cycle. What we need to look at is improving FME, so you don't have to do quite so many backflips to kind of take those rules and attach the rule to the feature, so that you can do that actual comparison with the feature. But yeah, it's some really innovative stuff going on here for data validation and compliance. I really like that term, compliance.
Yeah, I thought Brad from Edmonton asked an interesting question. They have some PLSQL rules in their database that normally fire as triggers and other things, and he would like to be able to call those out before putting data into the database. So basically, the business logic exists in PLSQL. Could we find a way in FME with SQL executors and doing something clever to kind of check that within an FME environment, so that if it fails, we still have control of things and we could route the data elsewhere? So I thought that was an interesting question that Brad had asked.
Yeah, definitely. Yep.
Now, are our friends from Atlanta, Lamar and David, still on the line?
Yes.
Hey, I want to, just me, Dale speaking, I just want to thank you so much for sharing this story again. I remember when I kind of accidentally stumbled into your talk years ago at Autodesk University, not even knowing it was going to have any references to FME, and was pleasantly surprised to discover the amazing stuff you're doing. So it's just wonderful to see you sharing your techniques. Also interesting to see how you've evolved it over the period of years since then, and glad to know that it's still really making good business sense to be using these techniques.
Yes, thank you for that, and thank you for your impromptu approach here at Autodesk University. That was very well timed, and I really did appreciate that. And to that end, I really want to see FME further advance within the CAD community. There's just so much that we could talk about, that we could do within the confines of FME, and we just barely scratched the surface. So for all you CAD managers out there and those who are really working in the AutoCAD environment, we have just scratched the surface on this, and I really want to see other people really expound on what we've started here. So thanks, Dale.
Yeah, you're welcome.
Okay, we are running a little over time, I'm afraid, so we are going to have to try and wrap it up. Coming up, if you follow our webinars, how Google and ESRI are going to kind of work together a little bit to get your data out of Google Map engines. That's later this month. And so just to close off, thank everybody for coming along. Thanks especially to our Colonial Pipeline friends, George and David, for presenting. And if you want any feedback, you can contact us, or I don't think they will be too disappointed if you contact them directly. Their emails are in this presentation that we're going to post up. And so with that, thank you, everybody. We'll stay online a little bit longer if anybody's got some online questions they want to fire off. Otherwise, I think we're going to say it's farewell from me and everyone here else at SAFE.